You know that feeling? After something really amazing, some big rush of joy, there's that little crash that comes after, that kind of emotional hangover. Well, it turns out that's not just in your head. It is a core part of how our brains are actually wired. So today, let's dive into this super intimate and honestly kind of weird connection between pleasure and pain.
I mean, it's one of life's biggest ironies, isn't it? We spend so much time and energy chasing happiness, looking for those awesome, rewarding experiences. But the harder we chase that pleasure, the more it seems to slip through our fingers. So what's going on? Why does that happen? Well, thanks to some mind-blowing advances in neuroscience, we can actually peek inside our own brains to get the answer.
Okay, so to really get what's happening, we need a quick rundown of how our brains even communicate. It's actually pretty simple. Our brains are packed with these cells called neurons, and they chat with each other across this tiny little space. The best way to think about it is like a game of baseball. You've got one neuron, the pitcher, who throws a baseball, that's a chemical messenger called a neurotransmitter, and the next neuron, the catcher, snags it. That's it. That's how signals get passed around in your head.
All right, so one of the most famous of these little baseballs is, of course, dopamine. Now, you've probably heard it called the pleasure molecule, right? Well, that's actually not quite right. It's a common misconception. What scientists now know is that dopamine is really all about motivation. It's the chemical that screams, "Whoa, that was awesome! You should totally do that again!" It's the molecule of wanting, not just liking. It's the drive that pushes us to go get those rewards.
And where does all this wanting and motivation happen? It's in a really specific circuit in our brain, basically a superhighway called the reward pathway. You can see how it connects these really deep, ancient parts of our brain. We're talking the ventral tegmental area and the nucleus accumbens, all the way up to our more modern, thinking prefrontal cortex. So whenever we do something that feels good, this whole circuit just lights up with dopamine.
Okay, now this is where things get really wild. Just look at the scale of this dopamine response. A piece of chocolate? Yeah, that gives you a nice little 55% bump above your normal baseline. Sex? About 100%. But then look at the drugs. Cocaine jacks it up over 200%. And amphetamine? An absolutely staggering 1,000% increase. Our brains just weren't built for that. They never evolved to handle that kind of massive reward signal.
And here's the real twist. The thing that changes everything. Neuroscientists found out that pleasure and pain are actually processed in the exact same place in the brain. They're not separate things. They're literally two sides of the same coin. And that is not a coincidence. In fact, it's the absolute key to understanding why chasing pleasure can go so wrong.
So, to make sense of this, I want you to picture a seesaw in your brain. A big old balance. When you're just chilling, not much going on, that seesaw is perfectly level. But the second you do something pleasurable, eat that piece of chocolate, get a bunch of likes on a post, dopamine gets released and whoosh, the seesaw tips down on the side of pleasure.
But here's the catch. Your brain has number one top priority job, to keep things in balance. It's a state called homeostasis. Your brain absolutely hates it when that seesaw is tipped for too long. Doesn't matter which direction. So it has these incredibly powerful, totally automatic systems designed to do one thing: bring that seesaw back to level.
And how does it do that? Well, let's use this fantastic metaphor. Every single time that balance tips toward pleasure, your brain immediately sends out these little gremlins to jump on the other side, the pain side of the seesaw. These gremlins are the brain's response team, its opponent process, and their only job is to counteract that pleasure and get things back to normal.
And this is where it gets so interesting. The gremlins are a little overzealous. They don't just bring the seesaw back to level. Nope. They keep pushing, tipping it an equal and opposite amount over to the side of pain. That is the after reaction. That's the hangover, the come down, that meh feeling you get after the excitement is gone. It's literally what goes up must come down, hardwired into our brains.
So what happens if we keep doing that thing over and over again? Keep exposing our brain to that same big dopamine hit? Well, you can probably guess. The brain adapts. It fights back. Those little gremlins on the pain side, they start hitting the gym. They get bigger, they get faster, and a whole lot more of them show up for work. This is neuroadaptation, or what we all know as tolerance. And it means you need more and more of whatever it is just to get that same first buzz.
And you can see exactly what happens right here. With this whole army of beefed-up gremlins piled onto the pain side, your starting point, your baseline, isn't level anymore. It's tilted toward pain. Suddenly,
You need that hit of pleasure not to feel good, but just to feel normal, just to get the seesaw back to the middle. And trying to get that original high? Forget it. It's basically impossible.
Now, if this keeps going on, something even more serious happens. Those gremlins, they decide they like it here. They literally back up a U-Haul and set up a permanent camp on the pain side of your seesaw. At this point, your whole hedonic set point, your baseline for pleasure, has fundamentally shifted. Your brain is now living in a state that's constantly, chronically tilted toward pain.
The scientific term for this whole situation is a dopamine deficit state. And it makes sense, right? The constant, massive overstimulation has forced the brain's reward system to basically shut down to protect itself. It becomes way less sensitive to dopamine, and it starts producing less of it too. And this isn't just some abstract idea. You can literally see this in brain scans. Look at the left. That's a healthy brain, and its reward circuit is all lit up, bright and active. Now look at the right. This is the brain of someone with an addiction just 2 weeks after they stopped using. That same area, it's gone dark. There's almost no dopamine transmission happening at all. I love how one scientist put it. The players on Team Dopamine take their balls and their mitts and go home.
So, what does this actually feel like for a person? Well, there's a word for it, anhedonia. It's the inability to feel pleasure. When your internal seesaw is stuck, tilted way over to the side of pain, all the simple things that used to make you happy, a great meal, hang out with friends, watching a beautiful sunset, they just don't do it for you anymore. Nothing feels good. It's the ultimate paradox. The chase for pleasure leaves you unable to feel any.
Okay, I know this all sounds incredibly bleak, but please hang on, because there is some really, really good news here. Remember that powerful force, homeostasis? The brain's deep, deep desire to be in balance? The very same mechanism that got us into this mess is also the exact thing that can get us out. Our brains want to heal. They are desperate to get back to a level playing field. So how do you do it? How do you reset the balance? Well, the process itself is surprisingly simple, but as anyone who's been through it will tell you, it is not easy. Step 1, you have to completely abstain from that high dopamine thing. Step 2, you have to wait, and this is the hard part. You have to give your brain enough time for those gremlins to get bored, pack up their U-Haul, and finally leave. But if you can give it that time, your brain will readapt. That seesaw will, eventually, become level again.
And the reward for all that incredibly hard work? It's this. It's getting back the ability to feel real, genuine pleasure from the simple things in life. When that seesaw is finally level again, watching a sunrise, really tasting your food, going for a walk, those things can light up your reward pathways again in a way that's actually meaningful and, more importantly, sustainable.
So what's the big takeaway here? I think it comes down to this really powerful quote from Dr. Tom Finucane. He said, "We are cacti adapted to an arid climate, and we are drowning in dopamine." Think about that. Our brains were built for a world where rewards were scarce, hard to find, and took a ton of effort. We're ancient survival machines. We're cacti, built for the desert. But we're living in a rainforest, absolutely drowning in easy, cheap dopamine. So the real challenge for all of us is to figure out, how do you live like a cactus in a rainforest? How do we find that balance in a world that never stops trying to tip our scales?